Okay, so what we're going to do today is solve quadratic inequalities. So what we want to do is get our variable by itself. Our variable is inside of here. So we're going to have to use the reverse order of operations in order to get it by itself. So remember our order of operations. So when we're moving stuff to the other side, we go this way, and addition and subtraction will be first, then multiplication and division, then exponents, and then parentheses. So we have a +3 on the end on the left side. We'll subtract because it's a +3. We keep our sign facing the same way, as all we did was subtract. No more addition or subtraction outside of those parentheses there, so we're going to move on to multiplication and division. 16, so 19 minus 3 is 16. Yeah. Keep our sign facing the same way because we divided by a positive number. We only flip our inequality symbol when we multiply or divide by a negative number. I'm going to rewrite that back up here where I've got more room. Take the square root to get rid of the square. Square and square root cancel. And square root of 4 is 2. If you remember from last unit, when we take the square root of this, if x plus 1 is 2, 2 squared is 4, but so is negative 2 squared. So this could also be true. Subtract 1 from both sides, we get 1. Then over here, and then we'll divide by -1, so we flip the inequality symbol and we get -3. Both of these are part of our answer. When we graph these on the number line, it's going to have to be a little small here, unless I can make this tiny. Nope, doesn't want to work for me today. Okay. So it'll just be a tiny number line, and that's okay. So we always put down 0, and then we've got +1 and -3, so -3 should be noticeably further away from 0 than 1 is. We've got open circles because we have less than and greater than, but no equal to. And our arrows. So we have x is less than 1, the numbers smaller than 1 are to the left, and x is greater than -3, those numbers are to the right. So we end up with that barbell shape that makes this an and. So we've got our number line, and we've got x is less than 1, and you must put the and, or if it's an or solution, x is greater than -3. There we go. All right. Number 2 is going to be really similar. This time we don't have a plus or minus on the end, so we can go ahead and divide by the 5 straight away. $80 divided by 5 is 16. Take the square root. On the left, we add 3 to both sides. 4 plus 3 is 7. Keep the inequality the same. On the right, distribute the negative. We get negative x plus 3. Subtract 3 from both sides. 4 minus 3 is 1. And divide by negative 1, so that inequality symbol flips. 1 divided by negative 1 is negative 1. I'll use black. That'll probably be easier to see. So we've got 0, we've got 7, and we've got negative 1. We've got open circles again, because we still don't have an equal to. We have x is greater. That doesn't look great. There we go. So x is greater than 7. The numbers bigger than 7 are to the right. Remember, number lines always go from smallest to biggest, so our arrow will point to the right. We also have x is less than negative 1, and that's going to go to the left, because that's where the numbers smaller or less than negative 1 are. Arrows point away from each other, so it's an OR solution set. There we are. Number 3, we have a plus at the end again, so we're going to subtract. Keep the symbol the same, because we just subtracted, we didn't multiply or divide. Now we divide by 4, so those two cancel, because 4 divided by 4 is 1. Keep the symbol the same, because we divided by a positive, not a negative. Now all we have left is the stuff that's being squared, so we take the square root. Add 6 to both sides. We get 12. Distribute the negative. Subtract 6 from both sides, we get 0. And then divide by negative 1, which flips the inequality. 0 divided by negative 1 is still 0, so that doesn't change. Doesn't want to work for me yet. Nope. Okay. So we've got 0. We've got 12. This time we have closed circles because we have that equal to. It's x is less than or equal to 12. So the numbers that are less than 12 are to the left. X is greater than 0, those are to the right. We get that barbell shape, so it's an and. So our answer is x is less than or equal to 12, and x is greater than or equal to 0. Sometimes instead of a number line, you'll be asked to graph on a coordinate plane like we did on day 2. In this case, you're going to have to get some points. We want to make sure we have the vertex so we know where to change direction. Remember, our vertex is negative b over 2a. B is 3. A is 1. I don't know why I'm writing so big. Negative 3/2. There we go, finally. Okay. That's not where that was a second ago. So now we have the x value, and we plug it in to find the y. Remember that when we square a fraction, we square the numerator and the denominator. And we need a common denominator in order to add or subtract. So 9 minus 18 is negative 9, minus 8 is negative 17. Over 4. So the vertex is at negative 3 over 2, negative 17 over 4. Okay. So that point is going to be negative 3/2 and then 4 and like a quarter. So it'll be right there. Now we want to have at least one point on either side. Doesn't matter what numbers we pick, but we can strategically pick some values that'll make our lives easier. So 0 is going to be on our right. So if we pick 0 for our x value, like, look how nice and easy that is. So we get the point 0, negative 2. That's a negative 17 over 4. That's why that doesn't look right. There. That looks better. Okay. So 0, negative 2. And then we want to pick a point on the left. Doesn't really make a difference in this case, so let's do negative 3. Negative 3 squared is positive 9. Remember that square means we're multiplying a number by itself, and a negative times a negative is a positive. Nine minus 9 is 0. And 0 minus 2 is negative 2. So we get negative 3, negative 2. I'll be right there. Okay. So then we make the bottom curvy because it's a quadratic, not an absolute value. Okay. So if you do this in pencil, something you can do is go back through and just put little dashes if you need them. If you want to do it in pen, you got to make sure that you're checking what kind of line you need ahead of time. I would recommend using pencil just because it's way easier to manipulate stuff. Okay, and now what we're going to do is the shading. So we need to pick a point that's not on our curve. 0, 0 is always going to be the easiest because you plug in 0 for x and 0 for y. If we get a true statement out, we shade there. Otherwise, we shade on the opposite side of the graph. So 0 squared is 0. 3 times 0 is 0. 0 plus 0 is 0. Minus 2 is negative 2. That is indeed a true statement. 0 is bigger than negative 2. So we're going to shade up here. And there we go. So any solution that we pick, try to get as close as I can, would be inside that green area that I just colored in there. So this would be a solution, this would be a solution, this would be a solution. And so long as we don't have a word problem, it doesn't matter if it's a decimal or fraction or if it's negative or positive, that doesn't matter. So long as it's just pure algebra, not a word problem. So we could pick any of those to be solutions. They all work because they're all inside that green area there that we shaded in. If it is a dashed line like what we have here, we cannot pick points that are on our line. If, however, like how we'll have on the next one, we're going to have a solid line for our curve, we could also pick points on that solid line because equal to. So equal, we can have a solution there. Now, if you're in on level and you get a calculator on your test, you are more than welcome to go into y equals 5x squared plus 7x minus 6. And we can see that our vertex is right about there. That looks like negative 1. Yeah. And we could pick points from here to graph. So if you're in on level, you're welcome to do that. Otherwise, we're going in here, getting our vertex. So there's the x value, and now we're going to plug it in to get y. Negative 7 over 10 minus 6. Okay. So negative 7 over 10, quantity squared is 49 over 100. Minus 49 over 10 minus 6. 49 over 100 times 5 is 49 over 20. (49 times 2 is 98, and 6 times 20 is 120. 49 minus 98 is negative 49. And negative 49 and negative 120. $169. Okay. Yeah. Okay. So 169 over 20 is about that would be 160, and then whatever 9 over 20 is. So about 0.45, I think. Yeah. All right. So we need to be able to get to negative 8. We only have 6 spaces, so we're going to have to go by 2. Okay. So negative 7 over 10, so that's a little over halfway to 1. And then negative 2, 4, 6, 8, right there. If it's not perfect, that's okay. It just needs to look like a reasonable place to put it relative to the points you have if it's not directly on one of the little intersections of those lines there. So now we're going to pick some values that are going to help us get 2 other points. We want one on the left, one on the right. Again, we can pick 0. That'll be a nice value for us to choose since everything will cancel out super fast. Zero squared is 0, times 5 is 0, 7 times 0 is 0. 0 plus 0 is 0, minus 6 is negative 6, so the point is 0, negative 6. Now we want to get a point on the left. Let's do negative 2. Again, doesn't matter. I'm just not picking negative 1 because it's really close to our vertex, and I just want to have something slightly farther away to help me make the curve a little better. Negative 2 squared is positive 4. 7 times negative 2 is negative 14. 5 times 4 is 20. 20 minus 14 is 6, and 6 minus 6 is 0. So the point we've got is negative 2, 0. Okay. This time we're going to have a solid curve. Come on. Okay. Remember, we do have to do shading. If we don't have shading, we have not graphed our inequality correctly. So 0, 0 is not on our curve. I'm going to pick that. Plug in 0 for x and y. Zero squared is 0, times 5 is 0. 7 times 0 is 0. 0 plus 0 is 0, minus 6 is negative 6. And 0 is indeed bigger than negative 6, so we'll shade up here again. If we got a false statement, we would shade on the other side of our curve. So again, any point inside of here would be a solution. And in this instance, because we have a solid line, we can also pick points on our curve. So all three of those numbers, or all three of those points that we found earlier, the negative 3/2, negative 17/4, the negative 2, 0, the 0, negative 6, those are all solutions as well because we have a solid line. So our solution set includes or also equals the values on our curve. Do one more. This one. So some of y'all noticed on your Unit 4 test that some of the ones that you were solving for were factorable. So if you notice, this one factors like that. Those are your x-intercepts, so there we go. So negative 9, 0, and 1, 0 would be the x-intercepts on this one. So if you can factor it and find your x-intercepts really quickly, that's a completely valid way to get points. And it can also make graphing way faster. So there's a point, there's a point. And then the only thing we would have to do now is find our vertex and actually draw the curve and do the shading. So just one more point. Okay, so x value of our vertex is negative 4. So negative 4 squared is 16. 8 times negative 4 is negative 32. Minus 9. 16 minus 32 is negative 16. Minus 9 is negative 25. So let's do a different scale on this one. So we need to get all the way down to negative 25. And if we do a scale of 2, that's not quite going to be enough. 2, 3, 4, 5, 6. But if we go by 5s, it will be. So it's okay for the x and the y axes to have different scales, but you need to have the same scale on the opposite sides of the same axis. So our negative x-axis can't go by 2 if the positive x-axis goes by 4. They have to go by the same amount on the same axis. Okay. So negative 25 and it's negative 4. Okay. We're going to have a dashed line. So again, I'm going to put the brakes in it in a second if this thing will work for me. There. And that's just easier for me to do. Okay, so now we need to figure out where we're going to shade. And again, you can pick whatever point you want. I'm going to do 0, 0 again. Zero squared is 0. 8 times 0 is 0. 0 plus 0 is 0. Minus 9 is negative 9. That's a false statement. 0 is not less than negative 9. Since we have a false statement, we shade on the other side of the graph, so we're going to shade all on the outside here. So anything on the outside, including stuff further down that we can't see, would be a solution. All of these. And then stuff out here that's not on our graph, but would be if we were able to zoom in and out. That's all good to go. It just can't be on the curve and it can't be inside. So anything on the outside there is fine. And there we go. Those are our quadratic inequalities.